number 1 says to estimate the area under the curve by using left Riemann sums on the given interval and for the given values of n. Show the graphs, delta x, and the grid points. So the purpose of this section is to estimate area under curves. So we are going to be trying to estimate this area here underneath this curve. And we're going to do that using Riemann sums, which are essentially rectangles. So in this section, we're essentially creating a bunch of rectangles and figuring out the area of all of these rectangles. So if you graph y is equal to x squared from 0 to 8, it kind of looks like this. I'm kind of elongating it just to make it easier to draw the rectangles. And they want us to use 4 rectangles to estimate the area. Now delta x, let me pull up the formula for myself. It's b minus a over n. What that's talking about is this is like your a, this is your b, that's your interval, then n is 4. So my delta x is going to be 8 minus 0 over 4, which is equal to 2. Now what that means is this is the width of the rectangles. So on my graph, I'm going to have 4 rectangles, and I'm going up to 8, and my width of each of these is going to be 2. So I'm going to go up by 2's here, so 2, 4, and 6. So I need to draw my rectangles, and these are specifically left Riemann sums. Now what that means is that the left corner of the rectangle has to touch the curve. Here, the left corner would touch the curve there, so it's actually not going to go up at all. On the second interval, the left corner would touch here, and that would be my rectangle. Here the left corner would touch here, that would be my rectangle. The left corner would touch here, and that would be my rectangle. So it is important to know what the height of each of these rectangles is going to be. So you can actually figure that out if you just plug each of these numbers into the function. So if you plug 0 into x squared, you get 0, which makes sense because that rectangle has a height of 0. If you plug 2 into the function, 2 squared is 4, so this is going to have a height of 4. If you plug 4 into the function, you get a height of 16. And if you plug 6 into the function, then you get a height of 36. So now to calculate this area, I'm going to add up or sum up all of these rectangles. So they each have a width of 2. So this is going to be 2 times 0 for that first rectangle, which really isn't a rectangle, plus 2 times 4 for the second one, because it has a width of 2 and a height of 4. So my drawing isn't really to scale. And then the next one is going to be plus 2 times 16, which is talking about this rectangle, and then adding up 2 times 36, which again, this last rectangle has a width of 2 and a height of 36. So if you multiply and add those up, then you should get 112. A a faster way to do this, because I know each of my width is going to be exactly the same, you can just factor out that 2 and then just add up the heights. So 0 plus 4 plus 16 plus 36, and that's equal to 112 as well. So that kind of saves a little bit of space. So this is an estimate. 112 is our answer, and this is the estimate for the area underneath this curve. And you can kind of tell that this is an underestimate, meaning there's still a lot of area. Let me mark it here. There's still a lot of area that we are not considering, or that's not included in this estimation. So this would be an underestimate of what is the actual area.